I feel like since we just did a hyperbola in the last video, we would go ahead and do number 13 now because it's also a hyperbola. So it says find the standard form of the equation of a hyperbola with the given characteristics and the center at the origin. So our center at the origin. So of course your origin is 0, 0, and that will be our h and our hk values. Okay, it says the vertices are 0, 3. So 0, 3 would be right here. That's a vertex. And 0, negative 3 right here. That's a vertex. So just from the positioning of my vertices, I know that this is going to open up, down, up, down. So a hyperbola that opens up, down follows this format. The y squared will come first. It's going to be y minus k squared over a squared minus, hyperbolas have a subtraction sign, ellipses have a plus sign, x minus h squared over b squared is equal to 1. Okay, I know my h and my k are both zeros, so really truly if these are zeros, it's really just y squared and x squared in my numerators. I really can clean this up just a little bit since my center is 0, 0. Okay, if the y squared comes first, our hyperbola opens up, down. If it's reversed and the x's squared come first, if the x's squared fraction comes first, then it opens to the left and to the right, kind of like on the x, on the x-axis. Left, right is x, up, down is y. So if your y squared comes first, it's going to open up, down. If your x squared fraction is first, it's going to open left, right. Okay, so what else do we know? We know the parabola passes through the point -6, +5. So if I wanted to make it look a little more realistic, -6, +5 is right here. It should pass through that point. Should be a little bit wider. Okay, should look like that. And then the bottom one would be wider too, but I'm not going to take too much time. Okay, so the 0.65, anytime they tell you -6, 5, anytime they tell you a graph passes through a point, you can plug that point in for x and y and figure out any missing information. So here's what we know. We know the center is at the origin. We know we have a vertex here. So underneath your y squared, you should have 3 squared. The number, if you have to move on your y-axis, that number is under your y's. So that's going to be 3 squared. 3 squared. Okay, so like I said a second ago, anytime they give you a point that the graph passes through, you can plug that point in for x and y. So let's do that. Let's plug in -6 for x. So I'm going to come up here and I'm going to plug in -6 for x. And I'm going to plug in 5 for y. So we'll have 5 squared over 9 minus -6 squared over b squared is equal to 1. So that would give me everything I need just to figure out what b squared is, and then we can come back and write the equation once we find b squared. So we have 25 over 9 minus 36 over b squared is equal to 1. So we want to solve this for b squared. So I think I'm going to need to subtract 25/9 from both sides. Subtract 25/9. So that will leave me with -36 over b squared equals 1 minus 25/9. So 1, I'm going to rewrite 1. I'm going to rewrite it 9/9 minus 25/9 in order to get the common denominator so that I could subtract. So now I'm going to have negative 36 over b squared is equal to negative 16/9. 9/9 minus 25/9 is negative 16/9. Keep the common denominator. If I divide by -1, divide by -1, it'll make these two sides positive. Divide by -1, divide by -1, it'll make those sides positive. And then I'm going to cross multiply in order to solve and find b squared. So that's going to give me 16b squared is equal to 9 times 36, which is 324. Now we'll divide by 16 on both sides. Divide by 16, so we have 324 divided by 16, and that gives me 20.25. So b squared, which is what I need, 20.25. So to write the equation, we needed b squared. We needed to know what b squared was. So now we know b squared, and we don't even have to find b because we just needed b squared. We know that b squared is 20.25, and a squared, which is underneath that y squared, that 3 squared, that's going to be 9. So I'm just replacing 3 squared with 9, and that is the equation of the hyperbola. That would be our equation. Okay, I think now that we've done the hyperbolas, let's do all of the ellipses. Number 18 is really kind of a good one to learn how to do ellipses on. So here we have, it says find the center, the foci, and the vertices of the ellipse. Okay, the center again is your HK. Center is your HK. So for us, that's going to be the opposite of this number and the opposite of this number. So it's going to be a positive 4 and a positive 1. So we're going to immediately go to our graph paper at positive 4, positive 1, and put a dot. The next thing we're going to look at, underneath the x's squared, we have a 9. So I always think we're going to move the square root of 9 to the left and to the right. So this is the square root of 9 to the left, right, because your x-axis is left, right, and those are underneath your x's. So that's how you know to move 3 to the left, 3 to the right. Square root of 9 is 3. So 1, 2, 3 to the left, and 1, 2, 3 to the right. On the y-axis, underneath your y's squared, and your y-axis is up, down, you're going to move the square root of 25 up and the square root of 25 down. So the square root of 25, of course, is 5, so you're going to move up 5 from the center. 1, 2, 3, 4, 5 up, and 5 from the center down. 1, 2, 3, 4, 5 down. Okay, because it's longer up, down, that's called your major axis, and your major axis has your vertices on it. So your vertex is going to be 4, 6. Let's see. Vertex with a smaller y value. So the vertex with the smaller y value is 4, -4. And your vertex with a larger y value is 4, 6. And your ellipse looks like this. We just do our best to make it look like an oval. Good enough. Okay. We said the center was at 4, 1. Center is at 4, 1. And now let's talk about the two foci. So foci are these two little dots. They're always on the major. So foci are on the major, the long axis, this way, in other words, not this way. They're on the long major axis, the longer one. They are on the major axis. C units, and I'm going to show you how to find C. C units from the vertex, or sorry, from the center. C units from the center. Okay, so this is how you find C. We always just say little c. Little c is found by taking a squared minus b squared equals c squared. So it's kind of like the Pythagorean theorem, only with a minus sign in between. For this reason, we say a squared has to be a bigger number. Because you're subtracting a squared minus b squared, you want to get a positive number. So a squared has to be the larger of the two. So in this problem, a squared is going to be the 25. And b squared is the 9. So c squared equals 25 minus 9. C squared equals 16. Take the square root, take the square root. We're only going to take the positive square root because it is a distance. So C is 4. So we're going to count from the center on the major axis. 1, 2, 3, 4. And that is, it's called the focus. 1, 2, 3, 4 from the center. And that's the other focus. So those are our two focuses, or foci is plural. So the focus with the smaller y value would be 4, -3. And the focus with a larger y value would be 4, 5. 4, 5. Okay, and if we have to, now we have to find it. And we've already graphed it on our graph paper up here. And our center was 4, 1. Looks like this one right here, 4, 1. Yeah, this one's the only other one that's a vertical ellipse, so it's got to be this first one.